Okay, the next segment will complete the details of onboarding models, publishing models, and how the Acumos marketplace is organized. So to start us off, uh, one of our data scientists, one of our modelers, Paul Triantafyllou, is going to, is that close? Okay, is going to take us through a quick journey in, okay, you've got a model, now what? How do you Acumos eyes that? Thanks.
All right, thank you, River. Hello, everyone. Great. Hi, everyone. My name is Paul Triantafyllou, and I'm going to talk about and do a little demonstration of how to onboard a Python model with Acumos. So if you've written a machine learning model or AI model, you've probably realized that you have a ton of choices. There's a variety of languages and toolkits and frameworks and all that type of thing to help you, build a model, hopefully at like a high level, and then use that model in some application that you have in mind. The challenge is there's usually a good amount of software engineering that's involved when using the model in your application. For example, you might have to define interfaces or APIs that others can use to invoke your model. That might be an HTTP server that you have to implement yourself. If you want to containerize it and deploy it, that's another set of hurdles that you have to overcome. So what the Acumos client libraries provide is a way to use these simple wrapper interfaces to define your model function interfaces in a native idiomatic way that is suitable for that language. And then you use the Acumos client library to then dump a model locally, so you can onboard it via the Acumos web API, or you could push directly to Acumos using the client library. So this diagram is just to illustrate that you write your model using a language and library or framework of choice. You use the client library to produce what we call the Acumos model artifact, and then you ship it off to Acumos. This slide just illustrates the point we're trying to make, which is the client library tries to get all the software engineering burden out of your way. So on the left side, you could write your own Python server and handler and, choose between which framework you want to use, like Flask or Cherry Pie or something, or Tornado. And then, learn what Swagger is and then use it to define an API that lets other users of your model know how to use it. Or you can just define it natively. For example, on the right-hand side, I use Python type annotations to define a function, which really isn't a model. It's just a pure function that counts the tokens in a list. And then Acumos would do useful things like generating interfaces around that function. Right now, we support content types like JSON and protobuf, and we handle that data exchange process as well. And then in a future release of Acumos very soon, we're going to have the ability to generate Swagger interfaces on top of your model, so that if you want to know what a model does, you just go to that UI. All right, time for a demo. Okay, so in this script, I don't use Acumos at all. This is just using the Keras machine learning library that maybe some of you have used. It's like a simplified interface on top of TensorFlow, and I like it a lot. So what we're going to do is use one of its pre-canned machine learning models, InceptionNet v3, which is an ImageNet classifier, and also some of its utility functions to pre-process the image input. And we're going to load this model and just predict on an image I happen to have in my directory that you may have noticed before in the demo that Manoop was showing. And we just have a couple of scuba divers. So So running this script, which I already did, because it takes a little time to actually load and classify on my CPU here. If you run this, what you see is the, I believe, WordNet tag, the class that is the most likely class associated with this image, and the probability. And I just printed the console, so I print a tuple out. So perhaps a few of you or many of you have gotten to the stage and you think, you know, now what do I do with this? I want other people to be able to use my machine learning model. So what you do is you install the Acumos client library using the pip package manager. We're on PyPI. And you import a few utility classes. So in this script, I'm going to define this prediction endpoint. And we use Python 3.4 or later's type annotation syntax to basically say that, you know, this function is going to have a single input of type bytes, and it's going to output this prediction type. And a useful thing that the client library provides is the ability to define your own type. Because you might have a very special use case. It might be a nested data structure or something. We're not going to force everyone to output a scalar or something like that. So here I use a Python 3.6 syntax for defining a new type. It comes from it's derived from the name tuple type. And I create a prediction type which has a label, which is a string, and a probability, which is a float. So nothing too crazy yet. So within this prediction function, which is a closure over the model we loaded in the previous script, what we do is we put the bytes of the image into a buffer, which allows the pill, which is a pill library. It's a Python image library that's installed by the pillow package. It allows it to open that image as if it were like a file-like object. And then we use the process images function that we actually wrote in the previous script to produce this pre-processed state of the input image. We use the Keras model that we loaded to predict on it. We unpack the decoded predictions, which Keras provides. And then we return this name tuple, this prediction object. So in, I don't know, about 10 lines of code, we've utilized the pre-trained model that Keras provides us. And all that's left is to instantiate an Acumos model. Here, I map the predict function to a perhaps prettier name or more descriptive name that others would see on my external API. I call this classify image. I add a little more metadata, and this always isn't necessary, but in this case, the pill package that's imported is actually installed by Pillow, because Pillow is a fork of pill. So I need to tell Acumos, hey, when you build my container, I want this package for pill. And finally, we create an Acumos session. If I wanted to push this directly to Acumos, there's an argument to provide the API, which is what Acumos instance should I push to. And then I dump it locally, which I've already done because it takes like 20 seconds. Yeah. That's a very good point. So the question was, where can I specify the version of a particular library I have? I didn't mention this, probably should have. The client library actually does a round of introspection locally. That's why we have this running on the client side and why you just don't send us a binary. So when we look at this function, which is a closure, and we recursively traverse it, we see that you're using TensorFlow, and we actually use the package distutils package to see what version are you using. So we already have that information. Right, exactly. We pin everything. So, because you don't want a little bit of dependency creep and then your model just breaks all of a sudden. Right, that could be a pain. In the future, we're probably going to move towards a more modern pip file format, which does, I think, a much better job of this type of recursive dependency freeze. And that's a new tool that the Python Package Authority is recommending people use. So we're probably going to move to pip files soon. So at this point, I've dumped this image classifier model locally on disk, and I'm actually going to baton pass to Guy in a little bit, and he's going to show you how you would onboard that via the web API. At this point, that would really be all you need to do to onboard a model to Acumos using the Python client library. We also have client libraries for R and Java as well. At this point, I'm ready to accept any questions people might have. Yes. Right. So it would be tough to, because we have to do some kind of data exchange. So at the end of the day, you're going to have some set of primitives that you're allowed to use to define that data structure. So if you had a list of dictionaries, there's actually a list and dict type that you use for type annotations. So it would be, for example, you know, if you could see my cursor, you do from Acumos dot modeling for list dict. And you know, for example, you could say you have a list of dicts, and they could have, I don't know, like a string to string mapping or more dicts or something like that. So you could, yeah, you would do something like that. So let's just say, yeah, that's it. So what we do underneath the hood is we look at this type and we actually map it to protobuf IDL. And a nice feature of protobuf is that there's a one-to-one mapping with JSON objects as well. And Google provides tools for that too. So we actually use that under the hood. So if you could define this thing in a protobuf message, and we don't want people to actually know they're using protobuf, that's more of an implementation detail. But if we could represent the message using protobuf, we could represent it here. Any other questions? What do I have left? Do I have? Yeah. Oh, there. You had a clock for me the whole time. So I have a few more minutes, so I'm just going to show the next iteration of. Oh, question. So you don't have to specify any packages typically. So when during the introspection stage, we see what objects you're using that require certain packages. So for example, if I imported matplotlib or something for visualization, that wouldn't get picked up because the predict function doesn't use matplotlib. And we also support using that requirements class right here, the ability to actually specify packages that you wrote locally. You know, people, you know, like typically organize their code in Python packages and modules. The client library will actually find those files locally and include them and expand the Python path at runtime so that there won't be any import errors. If the client library finds a reference to some kind of module that it can't find anywhere, it'll be a fatal exception, and it'll raise an exception saying, hey, I can't find this package, and you need to specify it using the requirements class.